Okay, guys, in this video, we are going to take a look at how to find the component of one vector onto another vector. So in this case, it's a component of v onto u. Okay, so what happens here? So let me show you. So imagine that you have a vector. So let me just draw a vector u, okay? And then another vector, so this is going to be u. And then you have another vector v, which has an acute angle with it. Okay, so with u. Okay, so this is, let's say, this is vector v. Okay, so this is vector v. So what is the component? So what you're going to do is you're going to draw a perpendicular line segment to u, right? So that this is going to be 90 degrees over here. And then the component is going to be the length of this line segment right here. Okay, and in this case it's actually going to be positive because component could be negative. So this is component of v on u. Now, how do we find it? Well, actually there is a formula for the dot product. So if you remember that the dot product is equal to, we multiply, right? Multiply the magnitude of the first vector times the magnitude of the second times cosine of the angle between them. So I actually showed you the same formula, but in a different format where cosine theta was dot product divided by each magnitude, but you can also rewrite it this way, okay? And then what you have here, so if this is your angle theta, right? Then how do you find the component? Well, you know that cosine theta equal this component thing, right? The red one. Cosine is like the adjacent side divided by the hypotenuse, right? But what is the hypotenuse? Magnitude of v. Okay, and so if you know that cosine theta is the dot product divided by the magnitudes of u and v, then from here you can actually figure out what is going to be the component by multiplying both sides by magnitude of v. So here is what you get. So if you multiply everything by magnitude of v, it's going to cancel, right? So because you're going to be multiplying, let me use a different color. So multiplying by magnitude of v on this side and also multiply over here. And then it's going to cancel here, and there is your formula. So it's going to be the dot product on the top divided by the magnitude of the vector that you are projecting onto. So it's important to note whether it's v on u or v on u, right? So remember that whatever is in here, that should be on the bottom, okay? Now, also one other thing, component could actually be negative. And how can that happen? Well, imagine that you have two vectors again, but this time the angle between them is obtuse. So you have one vector, this is u, and then you have another vector v. So that's going to be like this. Okay, so that there's an obtuse angle. Well, what happens then? Well, then what you do is you're going to drop a perpendicular not on u, right? But like continue drawing that line that u is on. And so in the opposite direction, and now you're dropping the perpendicular right here, and the component is this part, okay? And that will be negative. So if you have a obtuse angle, the dot product is negative, and so is the component. Okay, so now let's go ahead and start computing that. Okay, so again, the formula for the component of v, of v on u is equal to dot product on the top divided by the magnitude of whatever vector you are projecting onto. So this one right here, that's not the marker, and that one. Okay. All right. So let's compute that. Okay, so first we find the dot product on the top. So it's going to be 2 times -1 plus 3 times 4 plus 1 times -2. Okay, so that's on the top. On the bottom, we got magnitude of u. Now, when you find magnitude, do not include the negatives. I told you that multiple times. Don't do that because when you square them, they go away. Okay, so then this is going to be -2 plus 12. That's 10 minus 2. That's 8 divided by square root of, okay, it would be 1 plus 16, that's 17, and then plus 4, 17 plus 4, I think it's 21. So this will be 8 divided by square root of 21. Now, because the dot product is positive, that tells us that the angle was actually acute. Now, what happens with the projection? So the difference between the two parts is the component is always just a number, positive, negative, zero, whatever. But projection is a vector. Projection is a vector. So what vector is it? Well, let me show you on the picture right here. So see that red line? That is not a vector, right? That's just the length of it as the component. But if we turn it into a vector, right? So if we make this a vector, okay, then that's going to be the projection. So how do we find it? Well, we want a vector that has the same direction as u, but length equal to the component. Okay, so how do we do that? Well, it's very easy actually. So if you take vector u, if you normalize it, make it unit length, what's going to happen? So take vector u divided by its magnitude. What's going to happen is you're going to get a new vector that will have the same direction as u, but the length of it is going to be 1. So if you now multiply it by the component, that's going to have the length of the component and direction will be u. Okay, so this is going to be component in the direction onto u multiplied by u hat. Okay, so all I have to do is take the component, which is going to be 8 over square root of 21, and multiply that by u hat. So what is u hat? Well, we actually already know what the magnitude of u is square root of 21. And that's not a coincidence. You are going to have the same thing so that when you multiply them, in a second, we're going to distribute, that square root is going to go away. So let me not jump ahead. So let's just find u hat, right? Put a hat on it. So negative 1 divided by square root of 21. Then we're going to have 4 divided by square root of 21 and negative 2 divided by square root of 21, right? Negative 2 divided by square root of 21. Okay, now we're going to start distributing this guy to each part. And you notice how the two square roots are going to cancel each other out, and it's actually just going to be 21. And so I want you to remember that usually in the projection expression, you are not going to have a square root. Okay, so this is just going to be negative 8 over 21. 4 times 8, that's 32 divided by 21, and then 8 times 2, 16 divided by 21. Now, beware of the problem of fractions that are not reduced. Sometimes they won't care, and sometimes they will care. So you need to reduce just in case. So just to show you how to do that in Desmos, you're just going to type 8 over 21, okay? And if it's possible to reduce, which I don't think it is, but if it's possible, if you click on this convert to fraction button, that is going to reduce it for you. So that's going to be the same. I don't think any of these are going to be reducible, right? So like if you were to try this, it's just going to spit out the same thing, right? If you try that. And same thing with the other one. But generally speaking, just beware of that because it counted as wrong if you did not reduce it. In my case, that's not a problem. Okay, so let's just put that and see if that's right.